It's time to talk about some respiratory acidosis and alkalosis. This is a big topic. Later in the semester, we've got a whole section of the book on acidosis and alkalosis. And we're going to see that the respiratory system is one organ system involved, the urinary system is the other organ system involved. So what we're doing now is we're prepping you for that by talking about the respiratory system side of it. So you all already have that under control when we get to the full-blown coverage of this topic later on in the semester. So, the first thing to remember is let's talk about pH, all right? pH, as you learned back in Bio 156, the standard body pH for your blood and really for all your ECF is 7.35 to 7.45. Remember, pH is a dimensionless quantity. It has no units to it. It's the negative log of the hydrogen ion concentration, which means it's ultimately a measure of how many hydrogens you have, how many free hydrogens you have. If your pH is above 7.35, you are in a state of alkalosis. And if you are below 7.35, you are in a state of acidosis. So acidosis and alkalosis, either one of those is potentially serious. Your body is constantly trying to maintain. This is the homeostatic range. Your body is trying to do everything to stay in this range. And the two systems that mostly control this are respiratory and urinary. Respiratory by controlling breathing, you're taking in oxygen, getting rid of CO2. Urinary by controlling what it puts into the urine or keeps back into the blood. We'll talk about that later, okay? So remember here then, that's just one basic. You have to know this so well that you'll know it in your sleep, all right? Make sure you have this completely under control. Now let's talk about something else you've been talking about since Bio 156. We covered it in Bio 201 and we talked about it again now in Bio 202. We already have, we're going to talk about it a lot more. What does every cell in your body have to be making to stay alive? ATP. And what are the input materials? What two things do you need to make ATP? You need oxygen and you need glucose, and those combine to make ATP plus some byproducts. You make water, that's good, we can always use water. You make heat, that's good, because that maintains your constant body temperature. But you also make a toxic byproduct, carbon dioxide. So carbon dioxide is a toxic byproduct. You have to eliminate it from your body, all right? Now, always think of, just get this in your head right now, CO2 is acid. Whenever you think of CO2 in the body, think of CO2 as acting like acid. So what happens if you have way too much CO2 in your body? Your pH is going to go down, you're going to be in acidosis. What happens if you don't have enough CO2 in your body? Your pH will go up, you could be in a state of alkalosis, okay? So make sure you're solid on this. And always remember, CO2 works in your body like an acid. Okay, let's move on. Let's talk about the standard respiration rate. How many times per minute do you breathe? Well, the standard respiration rate in humans is 12 to 20 breaths per minute. The nurses always hate to have to do this. They just write down 15 and figure, fuck it. So 12 to 20 breaths per minute. Now, if you, we can talk about then variations on this rate. What would happen if you're breathing less than 12 times per minute? One term we can use to describe that is hypoventilation. Hypoventilation. Below the normal rate of breathing. Hypoventilation means less than 12 breaths per minute. Now what's going to happen if you breathe less than 12 times per minute? Well, you won't get enough oxygen, all right? That's a bad thing, all right? But the other thing you won't be doing is you won't be getting rid of enough CO2. If you're breathing, think about it. When you breathe out, that's CO2. Where did that CO2 come from again? Did it come from the atmospheric air? Is that CO2 you just breathed in a moment ago? No, there's hardly any CO2 in atmospheric air. It's only 0.04% of atmospheric air. So the CO2 in your body came from aerobic respiration. You're constantly making it. You made the CO2 and you did such a fine job. It was beautiful CO2, but it's toxic and you have to get it out. So if you're hypoventilating, if you're breathing less than 12 breaths per minute, you are not getting rid of enough CO2. Remember, how does CO2 behave in the human body? Like acid. So what will happen then if you are hypoventilating? Hypoventilation will push you in the direction of becoming what we call acidotic. Now, I don't specifically say acidosis because it might not necessarily push you all the way to acidosis, but it'll make you more acidic. And so what it will do is it will drop your pH. Your pH will go down if you're breathing less than 12 times per minute. That's hypoventilation. Now, on the other hand, what happens if you are breathing more than 20 breaths per minute? What do you suppose we're going to call that? Yes, you are so damn smart. We're going to call that hyperventilation. I'm sure you've used that word before. Oh, don't start hyperventilating. Hyperventilation, that would be more than 20 breaths per minute. And what's going to happen in this case? In this case, you're blowing off CO2. You're blowing off too much CO2. Therefore, you won't have enough CO2 in your body. Therefore, we say you may become alkalotic. Alkalotic, yes. This means you will be raising your pH, right? Stop and reflect on this for a moment. Is this clear? It should be. Because I told you before, CO2 works like an acid. If you're hypoventilating, that means you're holding CO2 in. You've got too much acid, so you're becoming acidotic. Your pH is dropping. If you're hyperventilating, you're getting rid of too much CO2. You're getting rid of too much acid. Therefore, you become alkalotic, and you will raise your pH, all right? So come back and look at this as often as you need to. This is very basic, but this is crucial to understanding everything from now on, okay? So let's now take a look specifically at what happens with CO2 in the body. So remember, the cells of your body are you made that CO2. It was beautiful. So you made that CO2, remember? So the CO2 is being made inside all the cells of your body. When they're doing aerobic respiration, you're making it as a byproduct of making ATP. Now, what's half of your body by weight? Water. We have the water inside the cell, the intracellular fluid, the water right outside of the cell, the interstitial fluid. So what's going to happen when you make CO2? It's going to combine with water, all right? Right away, it's going to combine with water. Now, what happens when CO2 combines with water? So now we're looking at a chemical equation, chemical reaction. But you don't even have to know chemistry. All you have to do is be able to count your damn letters. So, if necessary, sing the alphabet song over and over again to yourself until you're solid with those letters. And then let's count the letters up. So, first of all, between these two, how many total H's do we have? There's no H's here, there's two H's here, okay? Now, let's see, how many total C's do we have? Well, there's one here, there's none over here, so that's one C. How many total O's do we have? There are two O's here, there's one O here, so we have H2CO3. And this has a name. This is called carbonic acid. Carbonic acid is an acid. And remember, all the way back from Bio 156, or if you've taken chemistry classes, when you form acids, acids in solution always dissociate. And remember what actually is acid? Remember what is pH? Pauvre hydrogène. A French term, whenever you say French terms, you have to look down your nose at people and be snotty and arrogant and treat them as though they're inferior. Pauvre hydrogène, English pig dog. So pH is a measure of free hydrogens, and that's what all acids do. Acids dissociate to create free hydrogens. So H2CO3 dissociates. Strong acids strongly dissociate, weak acids weakly dissociate. This is a weak acid, which means that it will dissociate to some extent. Some will stay in this form, some will stay in this form, some will dissociate. So we're going to end up with a free hydrogen, all right? And then what are we going to have left over? If we take one of the H's off of this, if we have H2CO3 and we take one of the H's away, what are we going to be left with? We're going to be left with HCO3. And remember, hydrogen was positively charged. That leaves this negatively charged. And this is our old buddy that we saw on the very first day of class. This is called the bicarbonate ion. This is the principal buffer of your extracellular fluid, okay? So this reaction always happens inside of your body as you're making CO2. It's combining with water to make carbonic acid and then dissociated into a hydrogen and a bicarbonate ion. This is really the conjugate acid, they call it. This is the conjugate base. Now, let's go back to what we were talking about before. Let's say that you are hypoventilating. What is hypoventilation going to do? Hypoventilation means you're going to be holding on to CO2, all right? You're not breathing it out, you're holding on to it. That means that that CO2 will continue inside of your body to react with H2O, to form carbonic acid, to form free hydrogens. Therefore, hypoventilation is going to make you more acidotic. Your pH will go down. All right? Why? Because you are holding on to CO2. You are keeping it inside of your body. You're holding on to it. Hypoventilating, therefore, causes you to become more acid. We say acidotic, meaning you're being pushed in the acid direction. On the other hand, what's going to happen here if you hyperventilate? Hyperventilation. Well, now what you're going to be doing is you're going to be blowing off CO2, right? If you're hyperventilating, you're blowing off tons of CO2. Remember, CO2 works in your body like an acid. That means you're getting rid of acid. Therefore, this is going to push you in the direction of becoming alkalotic. This means you will be raising your pH. And this is how the respiratory system then either causes a problem or solves a problem. So if you're currently in a normal physiological state, if you're in homeostasis, your pH is between 7.35 and 7.45. Let's say you start hypoventilating, holding CO2 in, that could push you into acidosis, all right? And it will eventually. But imagine another situation. Let's say that you have, let's say you just drank a whole bottle of Maalox, of antacid. Antacid is basically just bicarbonate ion. So what happens if you chug, I don't know why anybody would do this, oh my God, but if you were to chug a bottle of antacid, you would have way too much bicarbonate ion in your body. You would be in a state of alkalosis. So what's your body going to do to try to protect you? You're going to start hypoventilating. Because what happens when you hypoventilate? You're going to hold on to CO2, and then your body will be trying to take you from a state of alkalosis and get you back to normal again. So that's why we don't really say acidosis here, we say acidotic. If you're normal, then hypoventilating is going to push you towards acidosis. But if you're in a state of where your pH is above 7.45, if you're already in a state of alkalosis, then hypoventilating would be the way your body would try to fix the problem by making you more acidotic, trying to bring you back towards normal. And the same thing could happen here. If you're in a normal pH and you start hyperventilating, yeah, that could push you into alkalosis. But what if you took an overdose of aspirin? Aspirin is acetylsalicylic acid. If you took way too many aspirins, which sometimes little kids do, they got those cherry flavored aspirins, a little kid will get into the medicine cabinet, eat an entire bottle of cherry flavored aspirins because it's candy and it makes you better, Mom said. So what happens then is you got a kid who's in a state of acidosis. So what's going to happen? Acidosis caused by the aspirin. So what's the respiratory system going to do? It's going to try to save your life by forcing you to blow off acid. So what would you expect to see in a little kid who's OD'd on aspirin? Frantically trying to get rid of acid, all right? See, that's how the respiratory system and the urinary system can both work to solve the problem. And problems created by other means can be solved by respiratory or urinary. So you can see here, I hope from those examples, the respiratory system could either cause the problem or it could solve the problem. And that's what we really want to get to, right? So go back over this video a few times. Make sure this is clear in your head. I want you to understand this now. So by the way, in the case of hyperventilation, we would be driving the reaction in the other direction. You see? What we're going to be doing now is we're going to be taking all the acids, all the hydrogens, recombining them into carbonic acid, then re-separating them into CO2 and blowing out the CO2. So see, that's the way this equation, this reaction works. And I want you to know that, depending if you drive it this way, you're going in the acid direction. If you drive it this way, you're going in the alkaline direction. So look this over well, because later in the semester, when we cover the urinary system, this will be one part of a much larger concept that we're going to be learning about the complete control of acidosis and alkalosis in your body. You're actually going to have homework problems where I'm going to give you someone's pH, I'm going to give you the concentration of carbon dioxide in their blood, and I'm going to give you the concentration of bicarbonate ion in their blood, and you're going to tell me whether they're in acidosis or alkalosis, what's causing the problem, and whether or not the other system is trying to solve the problem. So that's why we got to get this under control now, because later in the semester we're going to build on this. So text or email me with questions, all right? This is important.